We'll get to experience some new graph paper this section because we're going to talk about polar coordinates, and the graph paper looks something like this as opposed to rectangular that we're used to. It is the same chapter. No. Nope. So you had a test over ellipses, hyperbolas, parabolas, circles, right? That's done. So now we're going to talk about polar coordinates, and you'll have a test over that. So it's a separate test. The other stuff is finished. Okay? I don't know when we're just starting. I don't know how many days it's going to take us. Okay. So here we go. So first of all, we have to talk about the polar coordinate system. And we're going to compare it to what we're used to, which is the rectangular coordinate system. On the left, when we talk about rectangular, we know that we have a point called xy. It is a unique point. There is no other way to talk about an xy in our rectangular system. The x is your horizontal distance, the y is the vertical distance. You don't have to write this down if you know it and are familiar with it. Obviously, you're very familiar with it, okay? But we're used to our good old polar, or our good old rectangular system. The polar coordinate system has what we call a polar axis. So instead of the x-axis and the y-axis, we have one polar axis. Okay? And R is it has a point, any points that we plot there are called r comma theta, where r is the directed distance from the pole, and theta is the directed angle counterclockwise from the polar axis. Okay? So with our work with unit circles, a lot of this will be familiar. So far, so good? Questions you have on this? All right, so now how do we convert between the two? Yep, I'm sorry. We've got an r and a theta. R is your directed distance from the pole. Okay, that would be the origin in our rectangular coordinate system. And theta is a directed angle counterclockwise from the polar axis. Polar axis. Okay. All right. So next slide says, plot the point 3, negative 3 pi over 4, and then find 3 additional polar representations of this point. So we want to plot 3, negative 3 pi over 4. That means that we'll be 3 units out and negative 3 pi over 4 as our angle. Okay. Positive angles are always counterclockwise with the polar axis. Negative angles will be clockwise with the polar axis, right? So we can either say that we're moving 3 out and then using our angle, or we can go find the angle and then move 3 out. It doesn't matter. Good question. Will there be a negative 3? And it's possible. I'll show you why. Okay, because there's, unlike the rectangular coordinate system where a point is a point and there's no way to represent it in any other way, we have multiple representations in polar coordinates. Okay, not just with rotations that we can keep adding 2 pi on, but in other ways. Okay, so first of all, I'm going to go 3 pi over 4 in the negative direction. So clockwise is positive, counterclockwise is negative. So here's 1 pi over 4, 2 pi over 4, 3 pi over 4. And then I want to pull it 1, 2, 3 units out from the pole, and that's the point. You'll have to have a special graph paper, you bet. Okay, so I'll have a worksheet for you this time. Okay, now if I'm going to plot more than one of these on a single graph paper, I want you to give me that coordinate, 3, negative 3 pi over 4, so I know which one it is. Or if it happens to be letter A, you can call it letter A if there's multiple. Okay? So far so good, nothing earth-shattering there, right? Okay? Now, let's think about another way that we could have done that. How can we also get to this same place? What's an angle that's equivalent to negative 3 pi over 4? 5 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So an equivalent to that is 3 5 pi over 4. They get us to the same position. Okay, so that's one. Okay, what's another way that we could get there? What if I went pi over 4 up, but negative 3 back? Would that make sense? I'm going pi over 4 up, but not in the positive direction. I'm going back 1, 2, 3. Okay, this is equivalent to negative 3 pi over 4. Because if I move pi over 4 from the polar, from the origin, the pole, okay, I'm going pi over 4 up, but then the opposite direction of what I normally would, okay, takes me to negative 3 pi over 4, which is the equivalent of negative 3 pi over 4. Okay? Mm-hmm. Did I count wrong? 1, 2. This is the first circle, okay? Second and third, okay? So the circles coming out are like your normal x ticks and your y ticks, okay? So this is a circle of unit 1. This would be a circle of unit 2, and this would be a circle of unit 3. Okay? So 3 steps out. Okay? So far so good? All right, so let's find one more polar representation. What do you think? Mm-hmm. So starting at the pole, right? We want to go back 3 and down, right? So if we went back 3, negative 3, then down would be clockwise, right? Okay, so negative 3 pi over 4, okay? Negative pi over, not negative pi over 4, but negative, how many pi over 4? Because we already have our negative 3 pi over 4. 7 pi over 4, okay? Negative 3, 7 pi over 4. Okay, so far so good? All right, so that's the first type of problem that you're going to see. Okay, then we have to be able to convert these guys. So this should look similar to what we did with our vectors. Okay, we were finding magnitudes and finding directed distances, directed angles, right? So if we're going from polar to rectangular, okay, when we want to know what x is, we take the r times the cosine of theta. And if we want to know what y is, we take r times the sine of theta. Okay, let's think about that. I have a theta and an r. I went clockwise, right? Theta degrees, pulled out r units. If I want to know the x value, the x is adjacent, I have the hypotenuse, and I have the angle, so I'm going to say the cosine of theta is equal to adjacent over hypotenuse. So if I want to get the x all by itself, it's currently being divided by the hypotenuse by r, so I multiply both sides by r. Okay, so x is r times the cosine of theta. When I want the y value, I need to use the sine function, the sine ratio. So sine of theta is equal to y over r, opposite over hypotenuse. So I want to get the y by itself, I'm going to take r times the sine of theta. Okay. Going the other way, if I have rectangular, I have an xy, then if I want to find the theta, I have opposite and adjacent. So I will say the tangent of theta is y over x and use my second tangent function, right? So the tangent of theta is y over x. Once you find that ratio, second tan, second answer, and you get your angle back. And when I need the r, it's the hypotenuse of that right triangle. So x squared plus y squared equals r squared. So r will be the square root of x squared plus y squared. Okay, so let's see it in action. We're going to convert 2 comma pi, r is 2, theta is pi, to rectangular coordinates. So when we want the x value, we take r times the cosine of theta. When we want the y value, we take r times the sine of theta. So what's r? And what's theta? Pi, right? Okay. So what is the cosine of pi? Bless you. If you don't remember, cosine graph starts high and ends high, right? So halfway between 0 and 2 pi is -1. Okay. Now we're ready for the r sine theta. So when we want y, we're going to take our r, which is 2, times the sine of pi. If we don't remember what the sine of pi is, we can graph it. Sine starts in the middle, ends in the middle. Between 0 and 2 pi, pi is right here. So what is the sine of pi? 0. So 2 times 0 is 0. Okay. 2 pi in polar coordinates is the same thing as -2, 0 in rectangular coordinates. Which makes sense, right? If I now draw this as a polar graph, I have a radius of 1, a radius of 2, a radius of 3, if I draw them equally, and I am 2 out and pi over, so I want to pull out 2 and rotate pi degrees. There's pi over 2, 2 pi, or 2 pi over 2, so that's pi, which makes sense. It should be at -2, 0. So far, so good? Okay. All right, next example is the opposite way. Now I have rectangular coordinates, and I want to convert that to polar. So -1 is my x, and 1 is my y. How do I find theta? want the y over x, don't I? The tangent of theta is y over x. And 1 over -1 is -1, okay? So we're thinking about this, we're at -1, 1. We're over here in quadrant 2, right? Okay. So what is a 45? Ooh, I went too far. Tangent of theta is 1 at 45, right? So what's a theta at a 45-degree angle in the second quadrant? We're going this way, 45 degrees, 135. If you want to think of it in terms of degrees, what would it be in radians? 3 pi over 4, okay? Didn't specify which one it has to be in. You can have polar coordinates in degrees or radians, okay? So this is 135 degrees, or 3 pi over 2, 3 pi over 4, okay? And now we have to find r. So r squared is x squared plus y squared, right? So 1 plus -1 squared, right? So we're going to get 2. So what's r? Square root of 2. So our polar coordinate is square root of 2, comma, 135 or 3 pi over 4. Degrees and radians both work. I'm not afraid of either one. It kind of makes sense that it would be the square root of 2 out, right? And 3 pi over 4 up. But that would be that point. There's our radius and our angle. Really don't like the eraser on this smartboard. Okay. So far, so good? All right, that's the nibble I'm giving you today. That's all there is to it. Okay, there's a whole lot more to polar coordinates, but I want you to get comfortable and confident with this. Okay? All right, assignment's going to be a worksheet.